I notice I see an x squared, so I write down a parentheses with an x and another one with an x. There's an equal sign on the right-hand side with a 0, so I write that down. And I'm looking for two numbers that give me negative 12 when I multiply and negative 4 when I add. And that would be negative 6 and positive 2. So in the blue, I have now written down that quadratic equation in its factored form. So that's part A. Part B is then find the zeros. We did that a little bit earlier in our lesson. That means look inside the parentheses and tell me what makes those things 0. So for the first one, I know that that will be x equals 6. And in the second one, I know it's negative 2. So my zeros are 6 and negative 2.
Why do they end? Can you explain why?
So the question is, why do these things change signs from what I see inside the parentheses? It's because of what I talked about a little bit earlier in the bubble in the first page, which talked about the zero product property. And what that's saying then, if I look in between these things and I go, okay, well, what does that mean? That means that either that x minus 6 thing had to be the 0 on the left-hand side up there in the blue, or the x plus 2 had to be equal to the 0. One of them did. If I add 6 in the left side to both sides, if I go plus 6 here and plus 6 here, and I solve it, I see the x equals 6 in pink. If I subtract off 2 from both sides on the right-hand one, I see that the stuff on the left cancels out and I get negative 2 on the right. And that's where these zeros are coming from.
Thank you.
You're welcome. All right, so if I were to sketch a graph of this thing, here's what I know. I know that if I were to make a coordinate axis for this, I know that somewhere off to the right, there's the number 6. And somewhere off to the left, there's the number negative 2. And from what I learned up above in the pink, I know that those are my zeros, which means that's where I'm crossing the x-axis. And if I were to make a table of what's going on here and take a look, like let's say an xy table, and I put an x and a y in, the reason that that's happening is because when I put in a 6 into the parentheses up above, up here, 6 minus 6 is 0. So on the left I would have 0. 6 plus 2 is 8. 0 times 8 is 0. And that's why I get the coordinate 6 comma 0, which we see on the right-hand side with the pink dot. If I were to pick the negative 2, the same thing happens. That's why these are called my zeros, or in other words, that's why they cross the x-axis. I know that this parabola, if I draw it, will be crossing the x-axis at that location. And I know it's opening up because there's no negative sign in front of the parentheses. However, what I'm trying to figure out is, if I wanted to find this spot, I want to know where is this bottom point, the bottom, or in other words, the vertex of this parabola. One of the easiest ways to do this from the graph is to figure out the x value that is exactly halfway in between negative 2 and positive 6. And that's going to be at the location positive 2. Because between negative 2 and positive 2 is 4 units, and between positive 2 and positive 6 is 4 units. The way that I figured that out is I averaged negative 2 and positive 6. In other words, negative 2 plus 6 is 4. Chop that in half and I got 2. This is the x value where your vertex will occur. If you want to find the y value, shove that 2 in for each of the x's and see what happens. So, in the first parentheses, 2 minus 6 is negative 4. 2 plus 2 is positive 4. Negative 4 times positive 4 is negative 16. That means that that vertex is happening at negative 16. Or in other words, 2 comma negative 16. This is one way to do it. Let me show you another way that you could do it. We all have graphing calculators in our class. So I could go to my graphing calculator if I wanted to. You don't have to do this, you can just watch. And I could go to my y equals. And in my y equals, if I wanted to, I could type in the parentheses and I believe it was x minus 6, parentheses, times parentheses, x plus 2. Parentheses. And then I could graph that. And as I graph this, I see my parabola. And as I look at my parabola, I can see where I'm crossing the x-axis. Number one. Number two, I can't see the bottom of my parabola. That means my window did not go far enough down. So I'm going to change my window a little bit so I can see the bottom of it. To do that, I go to my window button, and that means I need to go down to where it says y minimum. Negative 10 was not low enough, so I change it to maybe negative 20. And then I graph. And when I change my window, I can see the bottom here of this thing. Now, that doesn't necessarily help me because I don't know what the coordinates are at the very bottom, or in other words, where my vertex is. But this very bottom of the parabola is called your minimum. So if you want to find that, the cool thing about these graphing calculators is they have a function that does that for you. Let me show you. If I go second trace, that takes me into the calculate menu. And you'll notice that on my calculator, number 3 says minimum. That means we're going to find the minimum value. So I arrow down to where it says minimum, and I hit enter. And what you'll see pop up on your calculator screen is something called the left bound. That means make your blinky go to the left of the bottom of the parabola. So already the blinky is to the left of my parabola. So I hit enter. And then it says, where's the right bound? You can go anywhere to the right of that vertex of the parabola. And then once you're to the right, and your blinker is to the right of that thing, you can hit enter. And then it says, where do you want to guess the bottom of this parabola is? So you just arrow to the left until you get to somewhere near the bottom of the parabola, and you hit enter. And what you'll see pop up on your screen is where the minimum value occurs. 2, comma, negative 16 is the minimum location of my parabola. The actual value, the y value, negative 16, is the minimum value, and it occurs when x is 2. So 2, comma, negative 16 is the vertex of my parabola. Number 5, almost done. Number 5 says write the equation of this thing in its vertex form. So if you remember, our vertex form was talking about the thing that looked like this. Y equals a x minus h parentheses squared plus k, where the h and the k were the vertex. So I look at my parabola and I'm like, oh, okay, here's my vertex right here. So I need the coordinates of that vertex. And it looks like I'm at 1 and negative 4. Does that look right? Mm-hmm. Which means that if I was going to rewrite this thing, I would have y equals a times x minus 1 quantity squared minus 4. And at a later point in time, I'm going to show you how to find the a. So I'm not going to do that for right now. Actually, I'll do that right now. It doesn't really matter. So in general, if you're trying to find the a, you need to have one more point from the parabola that you know for sure. It looks like to me, if I'm looking at these points, one other point that I know for sure that falls on this graph is this point right here. What's the location of that point? Negative 1, 0 is what it looks like to me. And what that means, if you remember, is that the x value is negative 1 when my y value is 0. So if I go into this purple equation, I can find my answer. And I can find my answer by, and I'm going to have to go to something else now, so just forgive me, I have to skip to the next page, a blank sheet here. So I had in my purple, if I remember, y equals a x was a minus 1, right, squared. Oops. Minus 4. That was my equation. And the point that I found on the graph was negative 1, 0. And that was my x value and my y value. What I do now is I plug those in. So now I write down 0 equals, I don't know the a, I'm looking for it. My x value that I know was on the graph was -1, and there's my -1. It's being squared, and I have -4. So in case that's hard to track, this -1 I shoved in there for the x. This 0 I shoved in there for the y. And now I'm going to solve the light blue equation to find my a value. So solving this equation, I have 0 equals a times -1 minus 1 is -2. That's being squared. Don't forget you have -4. I have 0 equals a times -2 squared is 4. Don't forget about the -4. I need to add 4 to both sides to undo that. And I get 4 times a, because a times 4 and 4 times a is the same thing, equals the 4. Or in other words, my a has to be 1. So this is kind of a boring a. Not really such a big deal. So when I go back to my previous slide, what that means is that the a that we see here, I could replace with the number that I found for the a, which was a 1. Or in other words, I don't even have to write it there if I didn't want to. So that's how you find your a. B, it says write this in its factored form. This is where we, when we do this, we just write it as our 2 zeros. And so if you go back up here, there was one of the zeros in the light blue. At this point, I'm going to write down the other 0. It's over here. I think that's at 3. Is that a 3? 3, 0. So if I'm writing this in its factored form, in case you don't remember, factored form means that I'm writing it as y equals a x minus √1 times x minus √2. So in our particular case here, the way I would write that is I would write down y equals, we already found the a, it was 1, and then x minus the first root, so it's x minus -1, or in other words, plus 1. And then the second one was a 3, so it would be x minus 3. So this pink equation is the factored form. Purple, vertex, pink, factored. So when you're doing the factored form, probably the biggest idea is look and see where your parabola crosses the x-axis, and whatever those x values are, think of the opposite number, and that's what goes inside your parentheses. For example, the first light blue point is -1, 0, so instead of -1 in your parentheses, you see +1. The second 0 was 3, 0, so since it crossed at 3, you're going to see in the second parentheses x minus 3. The general form. So if I take my purple and I change it into general form, what that means is I want to square out the stuff that I see in the purple. It means I go back and I look up here, and I'm going to ignore the orange 1 because it doesn't really do anything to my equation. I FOIL that thing out. If you remember the Joachim rule, that meant that I squared the first thing, so that was x squared. I squared the last thing, that's +1, and I multiply everything together. 2 times x times -1 is -2x. And then that was y equals, and don't forget about the -4 on the end. So the stuff that you see right here was what happened when I FOILed out that x minus 1 squared. And then in the pink, if I multiply the two parentheses together, these two parentheses together, that is, what I would see down below is I would see y equals x squared minus 2x minus 3. And you say to yourself, whoa, those aren't the same. But that's because I forgot to do one thing in the purple. What did I forget to do in the purple? Combine like terms, thank you. So I need to combine like terms. I see that these two things are both number things. So when I put them together, I see y equals x squared minus 2x, and 1 minus 4 is minus 3. And what they want you to understand is that the pink and the purple no matter which form I wrote it in, to